Here's a question about finding angular velocities, linear velocities, given some kind of a wheel. It's an 8-inch radius wheel rotating at 15 degrees per second. Find the angular velocity in radians per second. Well, remember, there are pi over 180 radians per second. Yeah, not radians per second. Radians per degree. So if you multiply degrees by pi over 180, you will get the number of radians. So to get angular velocity in radians per second, I take 15 degrees per second and I multiply that by pi over 180 radians per degree. Degrees cancel out. And what does this come out to? 15 pi over 180 radians per degree. Degrees canceled out. Radians per second. And what is 15 divided by 180? 15 goes into 15 once. That's going to be 1 and 30. I think this is 12. 15 goes into 180 12 times. So that equals pi over 12 radians per second. That's the angular velocity in radians per second. Now, it wants the angular velocity in revolutions per minute. I'll use both. I'm going to convert both the degree per second and the radians per second. I'll show that they'll both be equal. So it says angular velocity in revolutions per minute. I'll use the radians first. I have pi over 12 radians per second. I have to get it per minute. So I want to say there's 60 seconds, and I put that in the numerator per 1 minute. And that way the seconds will cancel out. Now I've got radians per minute, but I don't want radians per minute. I want revolutions per minute. When the unit circle, one time around is 2 pi radians, or 360 degrees. So I'm going to multiply this by, let's see, I want radians in the denominator, so radians will cancel out. 2 pi radians per 1 revolution, and radians cancel out, and I'm going to get revolutions per minute. So I have pi times 60 divided by 2 pi times 12. And let's see, 12 goes into 12 once, 12 goes into 65 times, and the pi's cancel out. I get 5 halves revolutions per minute. So that's a conversion with the radians per second. Let me convert the degrees per second. 15, it'll be the same kind of conversion, 15 degrees per second times 60 seconds per minute. And remember, one time around is 360 degrees times 1 revolution per 360. I'll just put D for degrees. The degrees cancel out, the seconds cancel out, and again I have revolutions per minute. And let's see, 15 times 60 divided by 360. 60 goes into 60 once, and this 366 times 15 sixths. 15 divided by 3 is 5. 6 divided by 3 is 2. 5 halves, revolutions per minute. So no matter if I use the angular velocity that is degrees per second or the angular velocity that is radians per second, I can convert them to revolutions per minute. Now to get the linear velocity, I must use angular velocity in radians. The linear velocity equals the angular velocity in radians per time times the radius. And don't worry about the units here. If you have the angular velocity in radians per unit time and you multiply it by the radius, the units are going to be whatever units the radius was in. So if it's in inches, it's inches, meters, it's meters, whatever, miles, whatever it is, divided by whatever units the time was in. So in this case, the radius is in inches, and they want it in inches per second. I have angular velocity in radians per second, so it's going to be inches per second. So this equals the angular velocity in radians per time, and in radians per time it was pi over 12 radians per second. I'm not going to write the units, times the radius, which is 8. So this is going to be 8 pi over 12 inches, whatever units the radius was in per second. And if I simplify that, it's going to come out to 4 goes into 8 twice, 4 goes into 12 3 times, 2/3. Let me get more room and write that better. 8/12 is equal to 2/3, 2 pi over 3 inches per second is the linear velocity. So remember, again, linear velocity is always the angular velocity in radians per unit time times the radius. So that's the answer for part 3. Linear velocity. Here's the angular velocity in radians per second, pi over 12. And here's the angular velocity in revolutions per minute, 15 halves, no matter which way it's calculated. Whether I use the degrees or if I use the radians, I still get 5 halves revolutions per minute.